Alright, it is week 1 of our temperature sensor Arduino project. Let's meet the team.
For our first sensor on the rover on Mars, we're going to use a virtual Arduino kit, and we're going to use a temperature sensor that can assess the temperatures that it measures at the extraction sites. When we harvest the ice at the poles, and when we melt it into drinking water.
This sensor is crucial because Mars is extremely cold and temperatures often drop below freezing, impacting how easily you can melt the ice into liquid water. If the temp is too low, the water could take longer to melt, as opposed to if the temperature is higher, then it'll be quicker.
We will execute this by attaching the temperature sensor to our rover and then measure the temperature at various spots near the poles. The Arduino will send a voltage signal to indicate the change in temperature, which will then display on an LCD, telling us temperature and if it is possible to extract at that point.
Okay, Kevin, what kind of sensor did we do and why did we choose that display option?
We chose the analog temperature sensor because the analog tends to give you more precise values, because digital is 1 and 0, so you can't really get precise increments off of a digital. And with these values, we're gonna put into a program, a script that calculates it into what we need, and we're gonna display this on an LCD. We chose the LCD because it's not only very bright, it's very bright, it's also cost effective for this situation.
Guys, Sydney just gave you a list of components for everything. Why are we using those? What's good about them? I don't know anything about them.
Why are we using the Arduino Uno 3? It's pretty big.
Well, yes, it's pretty big, but it's actually the perfect amount of processing power, and the other ones are a lot smaller, so they might not be able to suit our needs. We're also using the temperature sensor because it's the only one available to us, and it fits perfectly for what we need for the sensor. And finally, we're using the LCD 16x2 because it gives us 32 characters of space to write whatever we want between 2 lines, and it's the simplest LCD being able to effectively say what we need to say.
Why didn't we use a different kind of LCD or a different kind of display for our data? Why is that one? Is there a different kind? Is there different types of LCDs, or is there only that one?
There are different types of LCDs, but this one is actually the simplest to wire. So getting our temperature to our brain, to our LCD, that's the most streamlined version.
Cost effective.
Of course. The other one, because we would need to use more wires, it comes out to be a lot more expensive.
Okay.
Alright, what is this thing?
That's the potentiometer. It's going to limit how much voltage we let into our LCD and our temp sensor.
Alright.
Do we really need that many wires? Doesn't seem cost effective.
Well, if we want to have the LCD running and have it all connected to the breadboard for the temperature sensor, we do need all these wires.
They need to be green.
I can change the color if you want,
change the
but
color.
green wires, green LCD, okay?
So just to be sure, the breadboard connects to the base and then it all displays on the LCD.
Yes, it does. We have the ground and the 5-volt connecting to the positive and negative over on the breadboard, and as well as having all the ports from our Arduino connect to the LCD.
What's that?
That's the temperature sensor, so that's what's going to track our temperature. As you can see here, you change the temperature, it's tracking it, and yeah.
Wait, what's this?
Yeah, that looks
What's this whole thing?
This is the Arduino, this is the main Arduino. It's what's going to be hooked up to our rover. It has all of our ports that connect to our breadboard and all that connect to our LCD.
And it displays it in Celsius? Or
It's displaying it in Celsius here, so once it hits 32 or below, it will go say warning. I've seen the code here.
Pretty nice code.
Thanks.
This is our CTO, Sydney Wright, and she's building our temperature Arduino sensor.
Alright, so we're gonna add in the temperature sensor and have it connect to our breadboard and our Arduino. We're gonna and we're gonna add in a potentiometer behind it. This will act as a variable resistor for our temperature sensor, and we're gonna connect our breadboard to our Arduino. It goes to ground, and then positive will go to our 5-volt. And it's hooked up to an LCD to display. Yes. All sensor. So here's a live final result of our temperature sensor.
You're right here. Can you see?
Yep.
Okay. So what did you just do to show this?
All right, so with everything connected and the code we have right over here, the code basically tells the Arduino and the temperature sensor, it'll take the temperature and it'll project it onto our LCD here, and we have an if statement that'll check. If the temperature is below 32, it will send a warning saying there's a low temperature, which will help with our rover, telling us where the ice is and making sure that all of our components are at a safe temp.
And why 32?
Because it's freezing.
Yep. All right.
See, well, we have temperatures at 58, nothing. We go below, and we have a
slider.
warning.
Warning.
Low
Wait,
temp.
Low temp. And then make it go back up to a high temp. Boom.
Nothing.
No warning. Okay, Kai, what difficulties did you face when we were doing this project? Like, what was it like? What did you have trouble like dealing with?
So one of my difficulties was verifying the hardware connections, because as QA manager I have to check everything, make sure it's done right. So I couldn't fully ensure the wiring was connected correctly between the Arduino and the board that met the specifications.
Okay. Is there anything else?
Yeah, I had trouble like getting everybody in the room to like film and make sure everything meets the criteria of the project. But I solved it because I carefully reviewed the circuit against the diagram, making sure everything was connected tightly and everybody was in the room at the same time, making sure everything got done.
Okay. Do you think that the absence of people and then coming in later is going to affect how the video flows, or do you think it'll end up being okay?
No, I think it'll end up being okay because we filmed each part separately, and in the video we can put it in the correct order, making sure it flows well.
Okay. So how was this project in your part a learning experience, and how can you, like, going forward, make sure that everything runs smoothly?
So I learned that careful wiring and connection checks are essential for reliable hardware, and I can use this going forward because I can make sure everyone stays on track and that everything gets done as a group, making sure all requirements are met.
Okay. Sounds good. Thank you. Okay, Sydney, as our CTO, what kind of things that were challenging for you during the project?
What was challenging is one, learning how to use the virtual Arduino. It's slightly different than an actual Arduino. We don't have like all the sensors that we normally would. Also learning the coding environment is a little different than other coding environments like Unity or Python. So yeah.
Solid. Okay, how did you figure out how to like move past these issues and kind of expand?
I did some research on the virtual Arduino and like finding what sensors we do actually have available to us and learning about those. And I just worked my way through the formatting and stuff with the coding to learn.
All right, Jackson, as our field support specialist, what things were challenging for you in our project?
Well, a lot of this week I was sick out of the office, so that was especially challenging.
How did you move past that? Like, how did you like get yourself back into the project and immerse?
Well, I tried to do as much work from home as possible to still support the team, of course. And I researched components to give to our CTO so they could build the project as a whole.
Okay. And what would you say you can take out of this experience going forward?
Well, I've never used the Arduino setup at all, so being able to now use it properly, and I can also apply that to future projects.
Okay, thank you. Noted. Hey Theo, Kevin should be here in a second. Alright, now that everybody's here, what were some challenges you guys encountered and how did you overcome them? Also, I'd love to know what your most important takeaway is that you can bring into the upcoming projects.
One of the challenges we faced when trying to decide between digital and analog is that analog is more precise than digital, and if we can convert the analog directly, then we'll be able to know if it's underneath or above 32 degrees Celsius. 32 degrees is the Celsius point. The digital ones, they weren't as precise, they weren't as good. They were probably enough, but we don't take risks at this company, so.
Okay, thank you, Kevin. What about you, Theo?
Yeah, so I had some problems with figuring out how to use the Arduino online kit, because it's very different from in-person kits. And I solved that by researching, practicing, and going through all the different points on the Arduino kit. I also had problems figuring out where exactly the temperature sensors should go, and I pretty much also again researched and found where each thing should go and and where they have been on past rovers and plants that we have seen on Mars. And I think one of the biggest things that I learned was that you could pretty much always find an answer to something online. If you just take some time and research, you can find the answer.
Okay guys, thank you so much for coming to this meeting, and I appreciate all your feedback, and it will be noted. As the CEO of Aquastellar, personally, it was incredibly hard to try to plan the filming of the video around everybody's schedules and make sure that everybody was there at the same day, because we had some employers who were either sick or absent or were going to a college fair, and the rest of us were trying to manage the content and the different parts of the video and make sure that everybody had somewhat equal parts as per the rubric asked. However, we were able to solve this by just simply communicating with each other, texting, emailing, and when everybody came in, we worked together to get the project done and communicate our parts and fill in all the gaps that we were missing along the way. And I will use this as a learning experience, so I plan more going forward into the following Arduino projects for our next sensors and make sure that we are able to satisfy the rubric and also bring more of a creative component into the video.
Water reaching out. Go on, cut.
3, 2, 1, go. We'll execute this by attaching the temperature sensor to our rover and then measure the temperature at various spots near the poles.
What? Why is
Okay, ready?